simplifying surds using prime factorization. So we have a number, let's start with 20, of course. So the root of 20, that would be equal to, what's the prime factorization of 20 using the factor tree? So we have 2 times 10 and then 2 times 5. 2 times 10, 2 times 5. And the prime numbers are 2, 2, and then 5. So this would be equal to root of 2 times 2 times 5. So you look for the twin numbers, which is root 2 times 2. So obviously, it means 2, this becomes 2, the twin numbers are now 2, and then root 5. So 2 times 2 times 5, 2 root 5. So you could see the same answer right here. Now let's try this for the other number, which is 200. So let's move, I'm moving a little bit fast with this one. That will be 2 times 100, 2 times 50, 2 times 25, and then 5 times 5. 1, 2, 3. Yes, 5 times 5. Okay. So we would have root of 200 will now be equal to 1, 2, 3. So 2 times 2 times 2 times 5 times 5 equal to, how many twin numbers we have here? So 2, 2, that's actually 4. So it becomes what? 2. We have another twin number here as well, which is this 2. So 2. This also, what? 5. Then the only one the root will be affecting is going to be this guy here. So that would be 2 times 5, root 2. So all the twin numbers become 1, because it's actually 4, becomes 2. Root of 4 becomes 2. Root of 25, which is a twin number, root of 25 is 5. So the only thing left here is this guy. So we now have 2 times 5 is 10, root 2. So using prime factorization, you can easily find your square roots, and then you can also simplify your set. So this becomes 10 root 2, and you can see it right here, 10 root 2. So that's basically how you could try your hands on a lot more and be frequent with that. Let's try another one. Let's see square root of 50. Root of 50 becomes, 50 is 225, and then 5 times 5. So we have this, this, and then this. So this will be equal to root of 2 times 5 times 5. And the only twin numbers here is 5. The only numbers twinning here is 5. All right, so twin numbers are repeated as 1. So 5 root 2. So simple. So 5 root 2 is the simplest form of root of 50. Now, can we try and use this knowledge to also express numbers, or to find the cubic root of numbers? Let's try this. So cubic roots. We have, let's say, the cubic root of 8. This obviously is not a set because you get a rational number. Now let's express this number as a product of its prime. Its prime. That would be 2 times 4, 2 times 2. 2, 2, 2. But unlike square roots, you have to see a number that is multiplying itself 2 times. But for cubic roots, you are For square roots, you are seeing numbers that are multiplying themselves twice, or integers multiplying themselves. But for cubic roots, you are looking at an integer multiplying itself 3 times. So what's the cubic root of 8? So the cubic root of 8 will be equal to 2. So let's express 8 as a product of its prime. We'll have 2 times 2 times 2. This is which number is repeating itself 3 times? It would be equal to 2. Therefore, the cubic root of 8 is equal to 2. But then, what then would the square root of 8 be? So the square root of 8 would be equal to the numbers multiplying themselves 2 times 2. And then this last 2 does not have a pair. It is not twinning with any other number. So 2 root 2, we bring the 2 and then root 2. Therefore, the cubic root of 8 is 2. But then the square root of 8 is 2 root 2. We can therefore say the cubic root of 8 is rational. And the square root of 8 is irrational. Okay. Try these 2 examples and let me see. Using all the 2 approaches we used. So simplify one, root of 98, and then 2, root of 45.